The topic name is mole concept. And today we are going to drill much about percentage composition. Before we do anything, I need to remind you about a few things on slide 5, producer. There are a few things we need to look at. Please, I keep emphasizing this. That is a must do every day. Make sure as we start this lesson, you're having a pen, you have a notebook, you have a calculator with you. Make sure you have invited people who are in your house, most probably those who are still in O level, to come and attend with you this lesson. It is not only meant for candidates, those ones who are in senior 3, those ones who are in senior 2, those ones who are in senior 4. All of you can attend to this lesson and to be fruitful. Also, make sure that you log in to our website if you don't have an account yet. Make sure you create an account, sign up, create an account, and you'll be able to access all this work in details, okay? Plus other notes from other topics, okay? As well, if you feel like you want to come and be on the source, you can, when the term resumes, you can come to Koda High School. This school is found in Seta Bajo. I've always told you, off Seta Road. Reach there, go straight to the head teacher's office. You can first consult, get all the details. She's called Madam Tushemeriro Lydia. She will help you. She's a welcoming lady, a good lady, and she's a mother, okay? Okay, off from that, let us look at what we are supposed to cover in chemistry. When we go to our next slide, we shall see what we have been covering, okay? I want to emphasize those things, those definitions, those terms are very important. This topic is called mole concept, and you all know that we need to keep reminding you that mole concept deals majorly with determining or counting the number of particles. That's why I always say that be with your calculator, okay? We are going to be determining the number of particles, but in different ways, okay? At first we saw the video, we saw what happens in real life. Now we are in the real chemistry. Also, we have to look at a mole. I've always told you that a mole is just the amount of substance which contains 6.02 times 10 power 23, and that one we have said always that have to write it on top here. That 1 mole always be 6.02 times 10 power 23 particles, okay? Particles. That one, we always write it here in order to emphasize it. Please make sure you be with that. Once you have that unit, you are very safe. Also, have to look at another term, that is relative molar mass. Relative molar mass is the mass of an atom of a chemical element expressed in atomic mass unit. Okay? And the units we have grams as of now. We are dealing with grams. Once, if you have kilograms, you convert them into grams for easy calculations. Also, we have to look at relative molecular mass. We said the relative molecular mass can be the relative formula mass. They mean the same. They all mean the sum of the relative atomic masses of the constituent atoms of a mole. Or you can say just the mass of, total mass of a compound, okay? That means you'll be able to add up all the elements, but using what? Their relative molar masses. So those things are very important. If we go to the next slide, you can find there at least one of the things we did yesterday, okay? I think everyone knows the topic. Just first take it off. Yesterday, we ended by calculating, we are calculating from moles to, we are calculating from masses to moles. We are calculating from moles to, from masses to moles, okay? From masses to moles. And we had a number of examples. We can have one example for reviewing so that we'll be able to follow what next. We saw that a question which was saying calculate the number of moles in 160 grams of sulfur. And we saw in bracket there was S equaling to 32, meaning that is the relative molar mass of sulfur. If we can do that together, you find that if the question is giving you 160 grams of sulfur, 160 grams of sulfur, what is important here? What should you note first? We said here, when it is from moles to masses, masses to moles, there are a few things you should note. That one mole is equal to the relative molar mass, okay? Or can be equal to the relative atomic mass. All right? 1 mole, if it is a compound, if it is of a compound, it is equal to relative molecular mass. Okay? If it is of a single atom, it is equal to the relative atomic mass. Okay? This one can be calculated, and that's what we did at first. So let us look at the question. The question is saying you calculate the number of moles, and we said that once they say calculate for something, that means here it changes. With this one means that you have moles, you want grams. Now the question is having grams, that means we change this one. We say relative molecular mass stroke relative atomic mass, we get 1 mole. So we use these two things, and we are going to be applying them in today's lesson. That if you are given moles, that means you are going to be calculating grams. The grams go to your right. Okay? If you are given grams, that is the relative molecular mass or relative atomic mass, and you are asked to find moles, the moles will go to your right. Okay? So this one is having grams, that means grams are on your left and moles on your right, because that's what you're looking for. But before that, you begin with the standard figure. You say, we are going to be having the relative atomic mass. But what is the relative atomic mass of sulfur? They said it is equal to 32. You add there grams. Okay? Once you have that one, you come here and say 32 grams of sulfur contains 1 mole. Okay? Contains 1 mole. What about, we said here on your left hand side, you have to make sure you have 1 gram. 1 of sulfur contains, okay, 1 divided by 32. Because we said if 32 are in 1, okay, that means 1 will be in 1 out of 32. If 32 are having 1, okay, we say 32 people are going to share 1 bread. Okay? Now, what is that portion that each person is going to get? Okay? If 32 people are going to share 1 bread, what is that portion? That means you get that bread and divide it into 32 parts. Okay? You get a small portion which will be for one person. That is it. Then we go to our question. If you know what one is supposed to get, okay? That means what about if one person is going to get 1 out of 32? What about 160 individuals? We'll get what one is supposed to get times 160. That means it's going to be 160 grams of sulfur contains 1 out of 32 times 160. You get the moles. And here we got 5 moles. Okay? We got 5 moles. That is what we covered yesterday. And here you say 5 moles of sulfur. 5 moles of sulfur. Quickly, having understood this one, and at the end we summarized this one and we said to get the number of moles, you say mass given over the relative atomic mass. Okay? Then we said if it is for molecules, you say mass given over relative molecular mass. That's how we get this. Today, if we can go to the next slide, we are seeing what we are supposed to achieve in today's lesson. On the next slide, that one, we are seeing what are we going to be achieving today. Make sure that by the time this lesson ends, you are able to determine the mass of a substance from a given number of moles. Okay? Here we have been looking at grams helping us to get moles. Now we want to see how moles can help us to get the grams. We are just going to change here. We have just used this one from grams to moles. Now we are going to move from moles to grams. It's going to be easy. Okay? Then the second objective is going to be we are going to aim at determining the percentage composition by mass of a given substance. Make sure that by the time this lesson ends, you are able to determine the percentage composition of a given substance. Okay? There you have to use the mass. And the mass you are going to be using the 2 terms. That is going to be the relative molar mass and the relative molecular mass. We are going to be using those 2 terms there. Very quickly, if we can go to our next slide, we are going to see how we can, the question, at least we have one example that can help us know more about how to convert moles into grams, into masses. Let us take this one off. So we change here. But that one remains there. We are now moving from moles to masses. Moles to masses. And we are going to see our example number 1. What are those steps that we are going to be following to achieve that? The question is saying calculate the mass in 5 moles of sulfur. Calculate the mass in 5 moles of sulfur. Okay? We have 5 moles of sulfur. Okay? Here, we have those 2 things. We have 1 mole giving us the relative molecular mass or relative atomic mass. The relative atomic mass giving us the mole. But since here we are moving from moles to masses, we are going to use this one. 1 mole giving us the relative atomic mass. So what do we do? Do we have the relative atomic mass? No. We first put here the relative atomic mass. The symbols I'm using, yesterday we defined these symbols. We said this one is standing for relative atomic mass. Okay? This one will be of sulfur. Remember, it has been given in bracket that sulfur equals 32. The atomic mass of sulfur is 32. That means the relative atomic mass is 32 grams. Okay? We just add there the atomic mass unit, which is grams. 32 grams. Okay, having got that one, we begin with the first step. 1 mole of sulfur, we shall say that it contains 32 grams. If you look at, you say that is 1 mole, just get to know that there are 32 grams of sulfur. If we say there are 2 moles, that means you say that there will be how many grams? You just you multiply. This one is straight. We say that on the left-hand side, once we have 1, then we go straight to the question. Once we have 1, you are saying that in 1 bucket, there are 7 oranges, okay? In 1 bucket, there are 7 oranges. That means how many oranges are in 5 buckets, okay? It is a matter of saying 5 times 7, and you get the number of oranges in 5 buckets. They say 1 bucket is having 2 oranges. What about in 2 buckets? You just know in 2 buckets I will expect 4 oranges. As simple as that. You just come here and say 5 moles of sulfur contains 32 times 5 grams, and you get 160 grams of sulfur. I would request my producer to focus what is on the blackboard and the slide number, work on slide number 7. Work on slide number 7 and what is on the blackboard. I would like you to look at those 2 things. You see, slide number 7 is showing you are calculating the number of moles in 160 grams of sulfur. Here the question, when you are converting from moles to masses, you are converting 5 moles of sulfur into masses. And you just know it is the same thing. And you see it is true. Here it is 160 grams of sulfur in 5 moles. And the other side we are asking for the number of moles in 160 grams of sulfur. You see, it is very simple. You just interchange the steps. Okay? That is it. Let us go to the next slide. Let us go to the next example. Because that example is involving an atom. It is not having a molecule. Let us look at the one which has a compound. Okay? Let us look at the one which has a compound. That question is saying, question on the next slide. Question on the next slide. Question. Yes. Question, example 2. Calculate the mass of 0.1 moles of potassium carbonate. And you are given, they are saying given K39, C12, oxygen 16. Okay? So I can remove this and we look at that example. The example is saying you calculate the mass in 0.1 moles of potassium carbonate. Zero 0.1 moles of potassium carbonate. That's what we are going to calculate now for. Remember, we shall go back here and say what is given. We have been given moles. Okay? That means moles are on the left-hand side. Please consider that. What has been given should be on the left-hand side. And what is required on the right-hand side. That means here we have been given moles. That means 1 mole will be on the left-hand side, equaling to relative molecular mass. But do we have the relative molecular mass? No, we have to find it. And what is potassium carbonate? Potassium carbonate is K2CO3. Okay? That's one. We did first number of in our very first lesson. Please, if you didn't attend, make sure you visit the top television page on Facebook, and you'll be able to watch those videos. All that work is there. You will understand these things. We were able to see how you can come up with the chemical formula of a given compound. Okay? So once you have the chemical formula, you come here and say, what is the relative molecular mass? This one is the relative molecular mass. And we saw this one in our definitions. When we are reviewing this lesson, we saw the definition for relative molecular mass, and that's why I brought it on board, because I knew we were going to use it. Never wanted my students to be confused. Now we are going to look for this. We say it is potassium carbonate. Okay? Then we look for the relative molecular mass. Potassium, how many potassium atoms are there? There are 2. And potassium is, from what we have in brackets, we have potassium equaling to 39. We have carbon equaling to 12. We have oxygen equaling to 16. And that's what we have in brackets, that question. I mean, this one will be 2 times the 39 plus. Carbon is 1, to be 1 times 12. Plus. Oxygen, we have 3 times the 16. What is the answer? We have 78 plus 12 plus 38. Okay? Simple mathematics here. If you have a calculator, get 78, you add 12, you get 90. You add 38, you get 128 grams. Okay? Those are the grams we have. Is everyone with us there? This one is 3 times 16, that is 48. Here it is 138. Okay? That is our answer. Then we go back to our question. Our question is not aiming at getting the relative molecular mass. The question is requiring us to get the mass in 0.1 moles of potassium carbonate. Then we begin with 1 mole of potassium carbonate contains 138 grams. Okay? 1 mole contains 138 grams. Then we said once on the left hand side we have 1. That means you can be able to get what we have asked. We say 0.1 mole of potassium carbonate contains 138 times 0.1 grams, and that one we shall get 13.80 grams. Okay, that is going to be our right answer. Hopefully that now at least everyone is having some knowledge about how to convert moles to masses. You just need to first get the relative molecular mass or relative atomic mass. Once you have that one, you'll be able to find the number of the mass in a given number of moles. Okay? You'll be able to get that one once you calculate for RMM or RAM. Okay? So I would request you to first take a minute and copy the exercise on this. Exercise on converting moles to masses. On our next slide, we are going to do those numbers. If you can get in touch with me, can consult me. If you cannot, I hopefully the examples I've given, they will help you. Make sure you first do the examples, you practice them, then you go to exercise, you do the exercise. For the students from Kodai School, make sure when you are coming back to school, I'll be able to look at that work, all right, and mark it. Parents, I encourage you to supervise the students. Make sure they do some work, okay? Where necessary, attend with them, okay, to find out whether they are learning or they are just on TV, okay? I continue to encourage you to stay home and stay safe. Please stay home since you are able to study from home until the situation normalizes, okay? That is the exercise. Calculate the mass of all those numbers. You do them. We have there atoms, you have molecules, you have compounds there, okay? You'll be able to calculate for them. Where is copper 2 carbonate, make sure you're able to get the chemical formula of copper 2 carbonate, the right one. Lead 4 oxide, make sure you are able to get it. Okay, as well, once you get a problem, you can drop a comment on Top Television page on Facebook. We shall be able to respond to you. Okay, where you meet challenges, please be able to contact us. And whatever you want, what you see is missing, please drop there a comment on the Top Television page on Facebook. Hopefully that you have copied the exercise and you have picked those things which are up, whether I've said given, you have looked at the atomic mass of sodium, chlorine, calcium, copper, lead, oxygen, and carbon. Okay? So let us go to our next objective. The first objective was to make sure that we are able to determine mass from a given number of moles. Now let us look at the next objective, which is saying determining the percentage composition of a given substance. Okay? On our next slide, we can see how the procedures followed on how to get the percentage composition by mass of a given substance. You see, you can read that statement. You see, we can calculate the percentage composition by mass of each element or each element in a compound from the formula of a compound. We are going to be using a compound. That means you are going to be able to first identify the compound and identify the elements in it and identify the element they want us to calculate the percentage composition for. If you can say the next step is saying percentage composition of an element, how do you get it? You say mass of an element divided by relative formula mass or relative molecular mass times 100. Let us go straight to that. Don't forget, we are still in mole concept, and the chapter we are on now is percentage composition. We are on percentage composition. That's what we are on. And we have said that to get the percentage composition, you have to get the mass of that element. Okay? You divide it by the relative formula mass. That is always denoted as RFM. Okay? And we said the relative formula mass can be the relative molecular mass. Then you multiply by 100. And you all know that the percentage is in percentage. When we say percentage, we are referring to 100. Okay? So it is mass of an element divided by relative formula mass times 100. That's what we are going to be looking at right now. We can rush and go to our example 1. Example 1 on our next slide. Example 1, we want to see how we can apply this formula in our example 1. Okay? On our next slide, we are seeing calculate the percentage composition by mass of nitrogen in nitrogen dioxide. What do you note first? Nitrogen, okay, of nitrogen in nitrogen dioxide. Percentage composition of nitrogen in nitrogen dioxide. That's what we are going to look at. We have nitrogen as an element, and we have nitrogen dioxide as a compound. That is the compound. This is the element. Okay. And in brackets, they have given us that N nitrogen is equaling to 14, oxygen equaling to 16. Okay. So nitrogen is what? Nitrogen is N. Nitrogen dioxide is NO2. It is NO2, not 0,2. Okay? It is NO2, not 0,2. Then, once you have these ones, we can look at our formula. Our formula is saying mass of an element. What is the mass of this element? Nitrogen. What is its relative molar mass? Mass is 14, and we say 14 grams. Okay? N is 14, and that is 14 grams. What is the relative formula mass of this compound? The compound, we have 1 nitrogen, which is 1 times 14, plus oxygen, we have 2 times 16. I told you at start, when we are starting this lesson, when we are starting this topic, I told you whatever we cover from day 1, we shall be able to apply it in the subsequent lessons. Okay? Now you are saying that we are applying the knowledge of calculating for formula mass here. Okay? So 1 times 14, we get 14, plus 2 times 16, we get 32. And the answer will be 46 grams. Okay? The answer will be 46 grams. So we have the mass of an element. We have the relative formula mass. Okay? This is the relative formula mass. What next? We go straight to our, we give the answer. We can say here, from, because it's always good to remind the examiner the one who is marking you from mass of an element, okay, divided by relative formula mass times 100, okay? That means here we shall get 14 divided by 46 times 100, and we should be able to get, put it into your calculators, 14 over 46 times 100, you get 30.4%, okay? Okay, that is the percentage composition of nitrogen in nitrogen dioxide. You see, this one is very simple. What we have reached on now is very simple. Once we know what we covered in the previous lessons, because once you don't know this, you'll not be able to get this one. You'll be knowing the formula, but you'll not be able to get what to put to fix it and get the answer, okay? So quickly, let's go to our next example. Our next example is saying, on the next slide, on our next slide, let's go to the next example. We are seeing calculate the percentage composition by mass of oxygen in calcium carbonate. Okay? This one, I want you to put the steps in your head. Very few steps, just you need to be with the formula, and this one, just know the mass of an element, you get it. The relative formula mass, you calculate for it, okay? And you'll be able to just substitute and get it, and use your calculator very well. Remember, I told you yesterday that instead of playing other games that are not very important, please make sure you play around with your calculator and see where buttons are, so that it doesn't become an issue. Don't say that, I wanted to press 5, then I ended up pressing 6. No. Play around with the calculator now. When it is time for an exam, work becomes easy for you. Okay? We are going to now, they are saying mass of oxygen in calcium carbonate. Percentage composition by mass of oxygen. On our example 2, we are having oxygen, okay? Oxygen in calcium carbonate. Remember yesterday I told you, writing well can help you to score all the marks in chemistry. Writing well is a key in chemistry. Be neat, you'll be able to get all the marks. Now we have oxygen in calcium carbonate. Okay? What do we have? Oxygen. And this is an atom just. What is its mass? You have to get it. What do we have here? We have calcium carbonate. Okay? Calcium carbonate. We have to get its relative formula mass. Okay? Here we have oxygen, and we have to get the mass of oxygen. Remember, always I've told you that the relative molar masses of different elements can be got from the periodic table. Just visit the periodic table, you'll be able to see the atomic masses of different elements, and you just pick them and you add there what they stamp to be grams, the atomic mass units. Okay, so when you go into the brackets of that question, you'll find out that we have in brackets calcium equaling to 40, we have carbon equaling to 12, we have oxygen equaling to 16. All right? We have all that there in the brackets, so you should be able to pick. I told you it can either be put in the question, find it on the last page in the periodic table. Okay, because it is always provided. If it is not provided, please ask for it. Okay? You are supposed to be with a periodic table in the exams. Okay, so here we want the mass of oxygen, and we are seeing there oxygen is 16. We just say 16 grams. Now we want the relative formula mass of calcium carbonate. Okay, want the relative formula mass of calcium carbonate. We said the relative formula mass is the same as relative molecular mass, and therefore here we shall say it is going to be calcium is 1 times the 40. We have only one atom of calcium. Then we add carbon. Carbon we have 1 atom times the 12 plus. Okay. Oxygen we have how many atoms? We have 3 atoms. We have 3 times the 16. Okay. What do we get? We get 40 plus 12 plus 3 times 16. We have 48. Okay. This one you can do it without a calculator. Okay, just get 48 plus 16. That is the 48 plus 16. That is 60 plus 40. That is 100. Okay. That is the 100. You put it here. 100 grams. Now, if we have the relative formula mass and we have the mass of oxygen, what are we remaining with? We just say, we remind the examiner that from mass of an element being divided by the relative formula mass, okay, of that compound times 100, we shall be able to get the percentage composition. Therefore, mass of an element is 16 divided by the relative formula mass. Relative formula mass is 100. We multiply by 100. What is the answer? Please use your calculators. Use your calculators. Sorry, here is a mistake. Remember, on our formula it is saying mass of an element. If we look at this compound, we are having calcium carbonate and oxygen is an element. So we have O. But when you go to mass of oxygen, we find out that is we have 3 atoms, and then we say we have 3 times 16, we get 48 grams. Okay, so here the mass of an element we have 48 grams. So 48 divided by 100 times 100, what do we get? Here you use just simple mathematics. You just see here it is 100 cancelling with 100. You just pick your 48 and you add there the percentage. Okay? So here you should take note of it, that when they say you pick an element, you don't consider the atom itself. You consider how many atoms of it are in the compound. That means you are getting the element is percentage composition of that element in the compound. So we have to consider that there are 3 atoms. That means the percentage of oxygen in this compound is 48. You consider all. Okay? You consider all. Hopefully that one is noted. Okay? You consider all. The other side we had nitrogen dioxide, and nitrogen was just 1. That's why we just picked nitrogen here. This one was just 1 atom. We just picked it, but here we identified that oxygen, there are 3 atoms, and you need to consider them. Okay? Let us quickly go to our example number 3. On our next slide, slide 19, example 3. Let us look at example 3. Please remember to stay home and stay safe. Our dear directors, Pastor Jackson Senyonga and Pastor Eva Senyonga, they are helping you to learn when you are at home. Okay? So don't move around, stay home, learn the exercises we give, make sure you do them during the free time. Calculate the percentage composition by mass of oxygen. That one we are from doing that. I need the slide 19. Slide 19. We need to calculate the percentage composition by mass. Producer, give me slide 19. On slide 19, we are going to see that we are going to be calculating the percentage composition by mass of water in copper 2 sulfate crystal. Okay? We are going to calculate for water in copper 2 crystal or hydrated copper 2 sulfate. Okay? That's what we are going to look at. This one in that one. That means from our formula, we want to move straight to what we are supposed to do here. Okay? Because this one is going to be what we are calculating for. Okay? So we say mass of water, because that's what we are calculating for. Mass of water. Okay? Remember, I told you that these ones are always given. You find in brackets copper equaling to 64, sulfur equaling to 32, oxygen equaling to 16, hydrogen equaling to 1. Okay? They are all there in brackets. Okay? All in the periodic table. So when we say mass of water, what is water? Water is H2O. What is it? Hydrogen, we have 1 times 2. Okay? Plus. Oxygen is 1 times 16. What do we get? Please use your calculators and get the right answer. We get 2 plus 16. The right answer is 18. Remember, when you go to the question, you find out they are asking for percentage composition of water. And here, if you can see that, you can look at the compound very well. You find that there are 5 molecules of water. That means here we're going to say H2, 5. We are looking for this one, which is 5 times 18. The right answer becomes 90 grams. Okay? That means that is the mass of water. Then you go to the relative formula mass of copper 2 sulfate crystal, 5 water. This one will be equaling to what? Copper, we have 1 times 64. Sulfur, we have 1 times 32. Because sulfur is just 1, and we know sulfur is 32. Plus, okay? Oxygen is 4 times 16. Plus 5 times water. That one we have it already. We can just plus 5 water. That one we already have it here. So we are not going to repeat it. We shall be wasting time. That is 64 plus 32 plus 4 times 16, 64, plus 5 times water, we say it is 90. Okay? What is the answer? Please let us use our calculators and see whether we can get the right answer. Okay? For those ones who use their heads, you can say 64 plus 64, that is 128, plus 32, that is 160, plus 90, that is 250 grams. Okay? Yes, if you are fresh, you can use your head. But I don't encourage that. Use your head together with the calculator and press the buttons very well. Okay, now we said we shall always remind the examiner that from mass of an element, okay, here we shall say from mass of elements. Now, because these ones are many. Out of relative formula mass times 100. We get the right answer. We say mass of elements is what? 90 divided by 250 times 100. What is the answer? Please use your calculators and we get the right answer here. Okay? The right answer is 90 divided by 250 times 100. Okay? You get 36%. Okay? That is going to be 36%. Okay. So once you have this one, we shall say that a little bit to have achieved our objective. Please, can you check with me? Have we achieved the objective? Are we able now to calculate the percentage composition by mass? I would request my producer to give me the last slide, and so that people can be able to copy the exercise. I'll request for the last slide. Please check with me. Hopefully that we have seen how to calculate for the percentage composition of one element. We have been able to calculate for the percentage composition of one element, but when it is having very many atoms, okay, in it. We have seen how to calculate for percentage composition of a molecule within a compound, and that has been a water molecule, okay? So at least we are able to calculate the percentage composition. Remember, our objectives were to be able to convert moles into masses, to be able to convert, to be able to calculate for percentage composition, and that's what we have just done. All right? Please continue to encourage you to visit our website, that is www.codehighschool.sc.ug. Your teacher today, I remain as Saul Chamanywa. Let us connect next time. Thank you.